Hello out there, welcome to this tutorial on binomial expansion. In this video, we'll be looking at the binomial theorem. This is the second video of this topic. Remember to check the description section of this video on our YouTube channel to get the link to the playlist containing all the videos on binomial expansion, including the Pascal's triangle. So we start with the first problem. Problem 1. Expand 1 plus half x all to the power of 5. So in our solution to this problem, we're going to use the binomial theorem. So for the first term, it is going to be 5 combination 0. And the first term inside the bracket will go with the highest power of 5. So we have it as times 1 raised to power 5. Then the second term in the bracket is going to go with 0. So we might not need to bring it here. Then we go to the second term, that is plus. Now 5 combination 1, then times 1 raised to power 4. Where is the 4 coming from? 5 minus 1. Then times the second term to the power of 1, which is this subscript here. Then we are done with the second term. The third term is going to be 5 combination 2, then times 1 raised to power 3. The difference between the superscript here and the subscript, then times half x raised to power 2. Then plus 5 combination 3, 1 raised to power 2, then half x raised to power 3, this 3. Then the next term is going to be 5 combination 4, then times 1 raised to power 1, then half x raised to power 4, then plus 5 combination 5. This is now going to be 1 raised to power 0, which will still give us 1. We are omitting that. Then times half x raised to power 5. Then we now go ahead to simplify the combination, that is the coefficients. So 5 combination 0 is 1. So we have it as 1 times 1, since 1 raised to power 5 is 1. Then plus 5 combination 1 is 5. You can obtain all this from your calculator. Then times 1 raised to power 4 is 1. Half x raised to power 1 will still give us a half x. Then plus 5 combination 2 is 10. So we have 10 times 1. Then half x raised to power 2. Half squared is 1 over 4. Then x squared. Plus 5 combination 3 gives 10 also. Then multiply by 1, since 1 squared is 1. Then this is 1 over 2 raised to power 3 will give us 1 over 8. Then x raised to power 3. So we have it as 1 over 8 x raised to power 3. Then the next term is 5 combination 4, which will give us a 5. Then times 1. Then 1 over 2 raised to power 4 will give us 1 over 16. Then x raised to power 4. Then finally we have a 5 combination 5, which gives 1. Then times 1 over 32 x raised to power 5. Since 1 over 2 raised to power 5 is 1 over 32, then x raised to power 5. Then we simplify finally. 1 times 1 gives 1. 5 times 1 times half will give us 5 over 2, then x, plus 10 times 1 over 4 will give us 5 over 2. So we have it as 5 over 2 x squared, plus 10 times 1 over 8 will give us 5 over 4. Then we have 5 over 4 x raised to power 3. Then 5 times 1 over 16 will give us 5 over 16 x raised to power 4. Then plus 1 over 32 x raised to power 5. So with this, we are done with problem 1. So we go to problem 2. For problem 2, use the binomial theorem to expand half plus 3x all to the power of 5. So in our solution, the first term in the bracket is the half and the second term is 3x. So we are going to have our first term of the expansion as 5 combination 0, then half raised to power 5. Since it is going to be 3x all raised to power 0, which will still give us a 1. We go to the next term plus 5 combination 1. That's going to be half raised to power 4. Then the 3x raised to power 1 will come in because of the subscript, plus 5 combination 2 is going to be half raised to power 3. The second term will come in as 3x squared, then plus the next term 5 combination 3 half raised to power 2. This is going to give us 3x raised to power 3, then plus 5 combination 4 half raised to power 1. We now have 3x raised to power 4 plus 5 combination 5. The half is gone here. We now go for 3x raised to power 5. Then we evaluate the coefficient. 5 combination 0 gives 1, and 1 over 2 raised to power 5 will give us 1 over 32, plus 5 combination 1 gives 5, 1 over 2 raised to power 4 gives 1 over 16, then times 3x, then plus 5 combination 2 gives 10, 1 over 2 raised to power 3 gives 1 over 8, then 3x all squared will give us 9x squared, plus 5 combination 3 gives 10, 1 over 2 squared gives 1 over 4, 3x raised to power 3, 3 cubed gives 27, so we have 27x raised to power 3, plus 5 combination 4 gives 5, then 1 over 2, this is 81x raised to power 4, so we have it as 81x raised to power 4 plus 1, then 243x raised to power 5. 3 raised to power 5 is 243, then x raised to power 5. So we simplify finally. This is giving us 1 over 32. This is giving us 15. 5 times 3 is 15 times 1 over 16 will give us 15 over 16x. Then this is going to give us here this is 5 4, yeah, because 2 goes into 10 to give us 5, 2 goes into it to give us a 4, so the 5 times 9 will give us a 45 over 4, then x squared plus 2 here, this is 5, 2 will go here to give us 2, so 5 times 27 is 135 over 2, then x raised to power 3. Here there's nothing that can divide. This is 405 over 2, so plus 405 over 2 x raised to power 4, then plus 243 x raised to power 5. That is the final step for the solution of problem 2. We then go to problem 3. For problem 3, we are to expand 1 over x minus 2 all to the power of 4. In our solution again, the first term, remember, is 1 over x. The second term is going to be taken as negative 2. In this binomial expression, the connector is negative. So we are going to take it as negative 2. So we have our first coefficient to be 4 combination 0. This is 1 over x raised to power 4. Then the second term is not coming in for this, so this is going to give us plus 4 combination 1 over x raised to power 3. You still remember 4 minus 1, we go here. Then the second term now, which is negative 2 raised to power 1 plus 4 combination 2 1 over x raised to power 2 negative 2 squared plus 4 combination 3 1 over x raised to power 1, then negative 2 raised to power 3 plus 4 combination 4. The 1 over x is gone, so we now have negative 2 raised to power 4. So the coefficient now, this is going to give us a 1. Then this is 1 over x raised to power negative 4. We're applying indices here, since 1 over x is x raised to power negative 1. So negative 1 times 4 gives negative 4. Now, is it going to be plus? We have to look at the negative here, since the index is odd. So we're going to maintain the negative here. Multiplying it by this positive, it becomes negative 4, since 4 combination 1 gives 4. Then 1 over x raised to power negative 3. You still remember x raised to power negative 1. That negative 1 times 3 gives negative 3, 2. So positive times positive will give us a positive here. 4 combination 2 gives 6. Then x raised to power negative 2 times 4, since negative 2 squared gives 4. Then we also check the sign. You have to be very careful, since the connector here is negative. If it is positive, we can just continue with the plus, 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 plus. Because it is negative, it is not all the terms of the expansion that will be positive. So to get this now, this is odd. The index here is odd. So we are going to have minus here. Minus times positive gives negative. So we now have 4 combination 3, which gives 4. This is x raised to power negative 1. Then times 8. This is going to be positive here. So we have plus 1 times 16, since negative 2 raised to power 4 is 16. So we simplify out. This is going to give us x raised to power negative 4. 4 times 2 gives 8. So we have minus 8x raised to power negative 3. 6 times 4 gives 24. So plus 24x raised to power negative 2. 4 times 8 gives 32. So we have minus 32x raised to power negative 1, then plus 16. And that is all for the solution of problem 3. We then go to problem 4. For problem 4, use the binomial theorem to expand x plus 2 over x all to the power of 6. And expanding this, the power here is 6, and the first term is x, the second term is 2 over x, and the connector is positive. So we now have the first coefficient, which is 6 combination 0, x raised to power 6, then the 2 over x, which is going to carry the power 0, it will be 1, so that one will be ignored. Then this is plus 6 combination 1, x raised to power 5, 6 minus 1 is 5. Then the second term in the bracket, which is going to be 2 over x raised to power 1, then plus 6 combination 2, x raised to power 4, then 2 over x squared, plus 6 combination 3, x raised to power 3, 2 over x raised to power 3, then plus 6 combination 4, x raised to power 2, then 2 over x raised to power 4. We stated in the first lesson that the power of the first term and the second term in the expansion must always add up to give you the power for the expansion, which is 6. So if you see 5 plus 1 gives 6, 4 plus 2 6, 3 plus 3 6, 2 plus 4 6. Then the next one is 6 combination 5, x raised to power 1, 6 minus 5, then 2 over x raised to power 5. Then plus 6 combination 6, this is gone, so we have 2 over x raised to power 6. So we simplify the coefficient. 6 combination 0 gives 1, then x raised to power 6, plus 6 combination 1 gives 6, then x raised to power 5, x raised to power 5, then this one is going to give us 2x raised to power negative 1, since 2 over x can be written as 1 over x times 2, and 1 over x is x raised to power negative 1. Multiplying it by 2, we have 2x raised to power negative 1. Then the next term, plus 6 combination 2 gives 15, then x raised to power 4. And this one, 2 squared will give us 4, then x raised to power negative 2. Yeah, so we have it as 4x raised to power negative 2. Then plus 6 combination 3 gives 20, x raised to power 3. This is 2 raised to power 3 will give us 8. Then x raised to power negative 3. So we have 8x raised to power negative 3. 6 combination 4 gives 15x squared. Then 2 raised to power 4 gives 16x raised to power negative 4. Plus 6, since 6 combination 5 will give us 6, then x raised to power 1, this is going to give us 32x raised to power negative 5, then plus 1, 64x raised to power negative 6. So we get our final answer by simplifying. This is going to give us x raised to power 6. 6 times 2 gives 12, so plus 12 x raised to power 5 times x raised to power negative 1. What we just do is 5 minus 1, which gives 4. So we have x raised to power 4 plus 15 times 4 gives 60. Then x raised to power 4, x raised to power negative 2. So 4 minus 2 gives 2. So we have it as x squared plus 160. 20 times 8 gives 160. Then x raised to power 3 times x raised to power negative 3. So 3 minus 3 gives 0. X raised to power 0 is 1. So that is the constant term. That is the term independent of x. So plus 15 times 16. Then 2 minus 4 gives negative 2. So we have it as 240x raised to power negative 2. Then plus 6 times 32 gives 192x raised to power negative 4. That's 1 minus 5 is negative 4. And finally, plus 64x raised to power negative 6. And that is the final step for the expansion of x plus 2 over x all to the power of 6, which brought the solution of problem 4 to an end. So we go to problem 5. For problem 5, use the binomial theorem to expand x squared minus 1 over x all to the power of 4. So we go ahead to carry out the expansion. Remember, the first term here is x squared. The second term will be taken as negative 1 over x because the connector there is negative. So we have the first term to be 4 combination 0 and x squared to the power of 4. The first term in the bracket to the power of 4. Then the second term in the bracket is to the power of 0, so we ignore that. The next term is plus 4 combination 1. This is going to give us x squared to the power of 3. Then the second term in the bracket will come in. That's negative 1 over x to the power of 1. This one here. Plus the next term, which is 4 combination 2. It's going to be x squared raised to power 2. Then remember 4 minus 2 gives this 2. Then the next component there will be negative 1 over x squared. This is the subscript here, will give us this power. Plus 4 combination 3, x squared to the power of 1. Then negative 1 over x raised to power 3. And the last term, which is 4 combination 4, this x squared will not appear there. So we now have negative 1 over x raised to power 4. That's the last term there. So simplifying this, 4 combination 0 gives 1. Then this is going to be x raised to power 8. Remember your indices. Then again, since we have negative as the connector, the power here is odd. So it's going to be minus 4. Since 4 combination 1 is 4, this is x raised to power 6. Then x raised to power negative 1. Plus 4 combination 2 is 6. This is x raised to power 4. 2 times 2 here, x raised to power 4. Then this is going to give us positive. So x raised to power negative 2. This is going to be negative because the index here is odd. So we have minus 4 combination 3 gives 4. This is x squared. Then x raised to power negative 3. Then plus 1. It is going to be positive because the index here is even. So we now have it as x raised to power negative 4. Then we go ahead to get our final step by simplifying the coefficients. So this is going to give us minus 4. X raised to power 6 times x raised to power negative 1. 6 minus 1 gives 5. So we have x raised to power 5 plus 6. Then x raised to power 4 times x raised to power negative 2 will be 4 minus 2, which is 2. So we have it as x squared. Then this is going to be minus 4. X raised to power 2 times x raised to power negative 3. We just say 2 minus 3 gives negative 1. So we have x raised to power negative 1 there. Then finally plus x raised to power negative 4. So this is the end of solution to problem 5. And this is the highest we can take in this tutorial. I hope you enjoyed it. Please like and share this video. Remember to subscribe to our YouTube channel if you have not done that. Until we come your way again, goodbye.